Here we're going to be talking about exponent rules and simplifying things by using the exponent rules. I'm going to start off with an example that has 6a squared b cubed multiplied by negative 3a b cubed, all raised to the second power. Now the first thing to do is to take care of this 2 up here. How we deal with that is any numbers, any exponents below inside of that are going to get multiplied by that number. So exponents, raised exponents involve multiplying the powers together. However, the number that's out here in front, it's actually going to get raised up to the power above. So this is going to be actually the negative 3 is going to be raised to the second power. Okay, so we have here a negative 3, it's going to be squared. We have an a in the middle, technically that's a to the first, and then b to the third, and the powers of a and b are going to get multiplied. So what we're going to get is negative 6a squared b to the third. If we square negative 3, it turns into positive 9. And then a, if we multiply 2 times 1, we get a squared. 3 times 2, we get b to the sixth. Okay, so that's something to really watch out for. I multiplied the exponents here and here, but I actually raised the coefficient in front to the power above. Okay, now we have these two things side by side. When you have exponents that are on two terms, they're being multiplied together, what you're going to do is going to add the exponents together. So here what we're going to do is we're going to multiply the coefficients in front. Negative 6 and 9 will multiply together, and we're going to add the exponents. For a, that's 2 plus 2. For b, that's 3 plus 6. So negative 6 times 9 is negative 54. A to the fourth, b to the ninth. And that's going to be simplifying it down then by using the exponent rules. Now in this example we have division at work. So we're going to need to take care of exponents when we have division. When we have division, the exponent rules tell us to subtract our exponents from each other. So what we're going to get here is a 24 divided by 10. Now realize that the a underneath in the denominator has an understood exponent of 1. So that 1 is going to subtract from the 10 up above, 10 minus 1. For b, we're going to get 11 minus 3. So then that's going to be 24 divided by 10, a to the ninth, b to the eighth. Okay, now that's the exponents. These numbers 24 divided by 10, that can be reduced into the lowest terms. So we have to see what divides into both. In this case, we can divide both by 2, reducing it to be 12 divided by 5. So our final answer here in lowest terms would be 12 fifths, a to the ninth, and b to the eighth. On this example, we're going to have a few different exponent rules to take care of. The first thing I would suggest doing is taking care of everything raised to the 0 power. Anything raised to the 0 power is 1. So what we're going to do here is make this 6xy, 4x squared y cubed to the negative 2, and then that's all multiplied by 1. Now multiplication by 1 doesn't change anything, so if this changes into 1, we can immediately then just drop the 1. And just leave the two things that we have here, and that's it. And that takes care of the 0 power from the beginning. One thing also to notice here is that it started out with a power of 1. We don't have to include that anywhere else. If there's a power of 1, it doesn't change anything either. Okay, so that would be the first thing to do. 0 power changes into 1 and then it's gone. Okay, now we need to handle this negative exponent. To do negative exponents, anything raised to the negative power goes in the denominator and becomes a positive power or positive exponent. So all this stuff raised to the negative 2 power, to take care of the negative power, we move it down to the denominator underneath and make it a positive 2 power instead. And nothing else really changes, just that part. Now all this stuff here that's not being raised to the negative power, the 6xy, it goes on top. Okay, so we'll put that on top and all the other stuff underneath. Now what we're going to do is take care of the fact that this 2 is above all the other stuff on the inside of the parentheses. So thinking back to what we did a second ago, the 2 is going to multiply to the powers and raise the coefficient up to the second power. So this is going to change into 6xy all over 4 squared, 16, and then 2 times 2, x to the 4th, 3 times 2, y to the 6th. And now we're going to be able to reduce and simplify. There's a y on top. We can cancel that out with a y underneath to leave us 5 underneath. There's an x on top. We can cancel that out with 1x underneath to leave us x to the 3rd. So what we're going to get is just a 6 on top, all over 16x cubed, y to the 5th. And then lastly, we can write it in the lowest terms by reducing 6 and 16. Both of these divide by 2. 2 it goes into 6 3 times. 2 goes into 16 8 times. So this is going to reduce to 3 over 8 x cubed and y to the 5th. Okay, here we have another situation with exponent and exponent rules. And what I want to do on this one is take care of the negative power that's right here. How are we going to do that though when there's a fraction underneath the negative power? That's a little bit more tricky than the last example. Last example we moved everything to the negative power underneath. I'd rather not do that if it's all a fraction. So here's an exponent rule we can use. If you have a fraction being raised to a negative power, we can make it into a positive power merely by flipping around the fraction. So that's also called the reciprocal as well. So if we flip it around to the reciprocal, we can take the negative power and change it into a positive power. And so that's what I'm going to do here. I'm going to flip this around to be 8 over xy, and then that's going to be raised to the positive 2 power instead. Okay, and now what we can do is apply some of our exponent rules from the last few examples. The 2 will come in here and raise 8 to the second power, and then it's going to multiply to the powers that are underneath. Well, it's just x and y, and they both have a power of 1 up above them. So when we do this work, we'll do 8 squared is 64 all over 1 times 2 x squared y squared. And that's going to be now times this other term here. Okay, so now we're almost done. Now we've got these two fractions side by side. To do these multiplication of fractions, we just multiply straight across. So on top, we're going to get a 64x to the 3rd. On the bottom, we're going to get a 2 and x squared. And then the y's, we're going to add the y powers together. So 2 plus 4 is 6. So that's how that's all going to come together after multiplying. And then the last thing we can do is reduce and simplify. Notice there are 2 x's down here. I can cross out those 2 x's and take them away from the 3 on top, leaving us with just 1 on top. So that'll turn into 64x on top and 2y to the 6th on the bottom. We can then reduce 64 and 2 to the lowest terms. They both divide by 2. 2 divides itself one time. 2 divides 64 32 times. So that's going to be 32x on top, all over y to the 6th. And here we have one more exponent rule to take a look at, and that's when we have fractions as exponents. So 8 to the 4/3 power. Fractional exponents will always be somehow related to roots. So the way that it goes is a to the m over n power is the nth root of a to the m, or the nth root of a all raised to the n power. Ultimately, what you have to know really is that the number on top here in the power, the numerator, is the exponent or the power that it's being raised to, and the denominator is the root that is being taken. And we can arrange them either with the power above a inside the root or all on the outside of the root, depending on what's more convenient. In the case of a to the 4/3 power, we'll realize that this thing has a denominator of 3, and so that will be a cubed root. I'm going to choose to make it a cube root of 8, and then put the 4th power all above that stuff. So the cube root of 8 all raised to the 4th power. And this is good because I know what the cube root of 8 is. The cube root of 8 is 2. So that's just going to be 2 raised to the 4th power. And 2 raised to the 4th power is 16. And so that's how we can take a fractional power, write it as a root, and then take the root and raise it to the power.